telemetry, where we are. So it's a little bit of motherhood and apple pie across all layers, networking, application, and business. And what, well, IETF does and could even do in that whole domain. From the amount of people in the room, I'm kind of staggered. That means that that statement might be right or wrong. So monitoring, tracing, is that really a target for some real innovation? I think over the past couple of years, we've seen that it is. And let's go and, as I said earlier on, let's start across all layers and start with the networking layer that's most familiar to us. And if I go back a couple of years, that's what we had, right? We had command line interface, we had SNMP, we had syslog, and that's what we used to extract information from the devices. And we said, well, that's not super sexy. Necessary evil, and to be honest, also not really fast to go and extract data. It never ever gave us a complete picture of what's really going on the box, because if you look at the recent router, there is something like 250,000 different counters available. 250,000 different counters. Or classes of counters or types of counters, because if you look at, say, bytes received from an interface, that's one of them. But there is kind of a raft of others. What we were typically extracting was such really incomplete information, and there was sometimes not even in CLI to get to all of that information. And it was specific to a particular box. As a consequence, people weren't really looking at all that data because they couldn't look at all the data and it was really hard to operationalize. And we made that overall thing more fuzzy. By adding additional stuff on top, so you pile not only per device information, but also per flow information, or even per packet information with IOEM, then it's getting even harder to operationalize. So, well, we need to go and move to make this overall thing easier to automate, easier to consume, so that we ultimately are more easily able to reason about that network. Which means, well, we had to go and give us a way to get the entire set of data that we have on a box, so all these 250,000 plus counters, and get them in a digestible format over the wire in a common way so that we can go and operationalize that data and use the data as opposed to it just sits there. And I think this is pretty much what telemetry is. If you go with the original definition as you go to, say, Wikipedia or even what NASA used, telemetry is an automated communications process by which measurements and other data are collected at remote or inaccessible points like the network, and then transmitted over to some equipment where it's going to be digested. So we're going to go and use this in a relatively loose way because telemetry is kind of one thing for one guy and another one for another guy. So, but it's basically gathering operational information, be it from packets, be it from applications, and shipping it somewhere where it can be digested. And let's go with that for the time being, for today at least. With this, Benoit.
Thank you. Thank you, Frank. So we'll play ping pong game between the two of us during the session. So, okay, we need telemetry. So there are three enablers for telemetry in the network. First of all, don't pull, push it, right? If you ever try to create a BGP table via SNMP, well, you understand why. Now, the second one is analytics, right? It must be analytics ready. I will cover that. And the third one, it must be data model driven because it's required for automation. So let me show this to you, right? An interface. We are networking people. We know what an interface is, right? Show IP interface. It's a gigabit interface. Great. Now, well, I receive a syslog message. The syslog message is like gig or giga or whatever. The mapping, the name is not even the same, right? Now, if I receive, if I pull via SNMP, this is the IF index, the unique ID for an interface, right? Now, if I go into Yang, well, this is the IF dash index. We were clever to have the same semantic between SNMP and Yang. Great, but that's a different field. Now let's go to what? NetFlow and IP fix. This is an interface, but pay attention about that. I mean, we've got a different semantic. This is the ingress interface or the egress interface, even if we map it with the IF index. You see it coming, right? Now let's say that I need to analyze the AAA information. Well, in TechX Plus, that's something different. I see you're smiling already, but I mean, this is reality, right? In automation. Now, okay, I use radius. Guess what? It's a NAS port. And I speak here about the very simple information, which is an interface, right? We know what an interface is. But if we need to automate this, this is very difficult. So what are the solutions? Solutions are, okay, I'm going to develop an expensive mediation function that will match information from the IF index, the IF dash index, and if it comes from a syslog, I'll do a grep, and hopefully people will have implemented the right interface naming convention, and if this is NetFlow, I'll say, well, okay, there's extra semantic there. Or I'll be using the same data model in order to have the same semantic directly day one. And this is why this data model-driven management is required. What is important is the semantic, right? We don't care if you send this over JSON or XML or protobuf, right? This is irrelevant to me, but having the same semantic is key. The next thing we want is the analytics-ready data. Okay, great, I've got a time series of a counter. Okay, where did it come from? What is the information of the platform? What platform is this? Which iOS version? Is this like a deviation in Yang? Is this like a specific image from engineering? This information must follow the streaming information, right? Same thing about the data manifest, the how and the when the data were measured. If you go back to the old NetFlow, is this with sampling, without sampling, random sampling, whatever. But unless you follow, unless you use information along with the streaming, you won't be able to interpret this into your big lake, right? Now, you could say that data models defines what you want to stream, right? But it's equally important the how. How do you want to consume information? And this is a tooling aspect. So let's focus on the tooling aspect. There are plenty of tools for data models, right? I could have like 15 slides. Let me show just a couple of them. Piang to show what's in the model, the 3. There is this catalog there that gives you all the models that you could think of, right? Including the one from different SDOs. And I will come back to that point, right? There is IEEE and MEF and Broadband Forum and all this. So there are tools for that. For telemetry, there are some tools, we're not there yet. This one is the Advanced Netcom Explorer. You just go on a device and then you see, okay, what can you stream to me? And from there you subscribe and you get all information directly to you, the collector, right? Another one, this one is like 11 days old, Telegraph, right? If you hated pipeline, this one maybe is your friend. That's a way to basically have model-driven telemetry with what? gRPC, dial-in, dial-out, with TCP, with GNMI, right? So there are tools there in telemetry, but we're not there yet. Like Piang is the tool to start with for Yang models. We need this for telemetry as well. This one too, I mean, yes, we all want to go into this data modeling driven management and telemetry, right? This one will help the operators to move away from SNMP OIDs, from MIP OIDs to telemetry, Yang telemetry. So it's a mapping to say, if you were using these IF index and these counters, these objects in SNMP, this is the mapping to Yang. So there are some tools, but we are at the beginning. Now, if I try to summarize where we are in terms of network telemetry, at least one part of it, because Frank will be covering the parts, on the what, on the models, we are there. We have a specification of a YANG, of a netconf, a RESTconf, etc. The tools, we are there, right? We've got reference code. The industry coordination, you've seen that with the catalog there, where we try to coordinate what's happening in open source, in SDOs, even for vendors, etc. So what you'll see as a theme throughout this session is it's not good enough to just do IETF specifications. We need specification, tools, code, and coordination industry. Because if I look at the right-hand side for telemetry, well, guess what? We don't have the specifications yet after 4 years in the IETF. Right. However, we've got some tools there. And we've got some code. How come? Because the tools that are in there and the code is in there is not based on the IETF specification that we don't have yet. They are based on something else. Does it matter? Maybe not. My point is that we need all of them. All right? So now let's move into active OAM with Frank.
Do you want to take questions before, during the presentation or after?
Maybe it's easier after,
Okay.
so that we can go and condense this overall thing a little. Well, what you did is go and collect information from an individual device and reason about that. One layer up is, well, you might want to go and get a little bit of information about the overall network and how data has progressed. And we've been using ping and trace for quite some time. And well, more recently, a couple of years ago, we did one-way active measurements protocol and two-way active measurement, where you basically have a control channel between client and server, and then instructing how the test would go, and then you get more accurate information between these two devices. I think what I want to go highlight, these tools are there, were specified here, and the other good thing, and that's what Benoit was referring to, in order to get these things deployed and useful, we need something that looks like a reference implementation so that people can go and consume it. OWAMP was done relatively early on as part of Internet 2. There's also TWAMP code out there. You can grab it, you can containerize it, and you can ship it on, well, any platform that runs containers. Whether it's a router or an end host, you can use that to do real accurate measurements these days. Fine. Now, up-leveling the conversation a little bit. So we did observe and go and do what people typically refer to as streaming telemetry on a per-device basis. So getting all these 250,000 counters out of the box, or a subset of those. We can do active probing, but there is something missing, right? So how do you measure the live user traffic, which is kind of moving into the domain that, well, I care about, and that is in situ OAM, which means per packet telemetry, understanding what the packet does as it traverses through the network, i.e. the customer traffic and not probe traffic. So for those of you that haven't seen in situ OAM, what does it do? You receive traffic, might be streamed directly from the host. So you start this whole thing on the host itself or somewhere in the network at a domain boundary. You're adding metadata to the packet, and you need to find a place in the packet to add the metadata. That's the ongoing conversation that we're having here. And you're dropping in information that, well, it matters to you in order to understand what the packet does in the network. If you're interested in understanding where the whole thing accumulates delay, then you would add timestamps to it. If you're just interested in how it progresses through the network, you're adding node IDs to it. If you're interested whether it follows the right path, the path that you were trying to go and preset by using something traffic engineering, be it segment routing, be it RSVP, whatever, then you would go and put pieces of a secret hop by hop so that you can either later on reassemble the secret and check you're on the right path, or you can't, and then proof of transit fails. That's what we're doing in the SFC working group, right? What we decided early on is, well, we don't want to go and get locked into one or the other, well, what I would call parent protocol, because many people run different protocols, but we want to go and have one set of data fields that everybody that is subscribing to this particular technology would support. So we started a draft, and that draft is adopted in IPPM, where we're just defining the data fields of what you carry, i.e. timestamp, node ID, proof of transit marks, sequence numbers if you need them, and the likes. So we have information that we carry on a per node basis, and I mentioned some of that. We carry things that are just applicable to a set of nodes, if you just want to go and prove the transit to a set of nodes, and there are certain things that you only need edge to edge. So if I want to go and derive the network traffic matrix, maybe I just all need is sequence numbers between here and there, and I can understand where the drops are and where packets are put in and spit out. We can carry those things in various protocols, and I think that's the journey at hand that we're doing. And well, that's a journey, because there's many protocols, and there's many protocols that have capability to carry metadata. And there's many protocols that we can go and insert that metadata into. And well, I'm mentioning a few. There is a working group draft in NSH, and we are, well, debating how to get that into V6, and even more so into V4. V4 is hard, right? Everybody runs it, but nobody, well, officially wants to go and touch it anymore. Maybe we need to do that. So from a standardization process perspective, we want to go and draw a picture. Everything that is common is done in IPPM. Data formats, how do you operate the whole thing? We need a Yang model for the whole thing, to Benoit's point, in order to operationalize IOEM. And, well, you need to go and extract the data from the box, again, something uniform, so that other people can go and digest it. Because that's just one source of information, and we might have multiple other sources of information as we will go and progress. And then, well, you need to go and do the NCAP game, and NCAP isn't easy. So we have individual working groups spinning on an NCAP, then you go back and forth between IPPM. It would be nice if we had something that would streamline that process. We don't have that so far. But from a messaging perspective, well, we have this as a standards effort. How do we get there? We started this journey not with a document. We started this journey with running code. So when we first started to talk about IOEM at IETF in Berlin, 3 years back? Not sure when we were in Berlin. We started off saying, well, look at this. We've done an implementation in vector packet processing as open source, and you can go and look at it and run it. Since then, guys in Belgium at the University of Liège, so Professor Benoit Donnet and team, they've done a version for the Linux kernel, and they're continuing to evolve that. I just heard that they're implementing the 04 version of the data draft. So we'll have something for the Linux kernel that is pretty modern very soon. And people have been embarking to go and put the overall thing into Silicon based on that. We've done an open daylight implementation for kind of how to go and configure the whole thing. That's based on a really old release, Carbon. So that came out a while back and is part of the SFC code there. But I wanted to again highlight, we did the tool chain, and it was really running code and then kind of how to embark into the standards journey. And yes, it changed, but still, I think it is what got people interested. The next steps are operationalizing the thing, and I think we're not really there yet. We started the first steps, but operationalizing means how do you go and consume this in an automated way, configure it in an automated way, so that aligns with everything else. So I think the natural point is your favorite word. It starts with Y, right?
Yes. So how would you give a scorecard, on spec, on tools? You mentioned code and, industry adoption.
I never ever thought about that question, which is why we have a slide on it. Yeah, so we're doing well on, I think, IETF specs. Yeah, it could go faster, but yeah, coordination is coordination. Tooling-wise, yeah, not really. Yeah, I could go and give me even a little bit of a C maybe, because there's something in Open Daylight. Is it really maintained? Not so much. We have reference code. That's cool. Industry coordination, I think we can go and chat about that later on how far we want to go, because I believe that if we can go and find more of a commonality between what happens at layer 5 and above from a tracing perspective and what we do at layer, well, up to 3, we would do a great benefit to the industry. So let's go and up-level the conversation to what happens at application layer. And how do we rope application visibility into the overall flow, so that we do something that is not there only for the network operator, but also for the app developer and the guy who runs the app, be it the CI/CD person or some other operational team. Because the funny thing is, if you look at the questions being asked, they're very similar. So, which is why, well, look at them, right? My requests are slow. Why? Who do I need to blame? If I have my tracing tool, it tells me the HTTP request is slow eventually. That's cool. I already get that to that level. But drilling down further, can I blame the host sec, the network, or even do I have to go blame myself? I don't know. Database lookup is slow. Why? So all kinds of these why questions when it comes to, I can't really reason about why my application does something that I didn't want to go and have. And if you look at the landscape today from an application developer's perspective, you're doing stuff in multiple frameworks, and you have multiple messaging systems underneath. Yes, well, we're moving to a world where everything is a little bit easier with containerization. Everything runs on Kubernetes eventually, and yada, 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 but we need to go and get there, right? Not every single request yet is based on HTTP. But what you do as an application developer is today, you've got to go and pretty much marry yourself with one of the many frameworks on the right-hand side. Because you're going to go and instrument your code with their APIs, then you run their libraries to go and get the thing into their particular tracing environment and stats environment. And that means, well, you go and if you create something, you go with that marriage and you keep with that marriage for quite some time. And breaking up is hard. Can be done like in the real world, but it's hard. So if you look at this overall picture a little bit, like you have the developer guy that needs to go and instrument his code. Then you have an instrumented library that typically comes with your vendor package today. Then you have something that exports this whole thing. And in many cases, even the tracing backend is linked to the agent and the exporter. So all of that is one particular vertical ecosystem. And well, then you have the consumer on the other side. So we don't only have, like in the network operating space, the operator, but we'll also have the developer that has a say here. And the question is, can there be standards? Because, yeah, well, multiple silos, everybody doing something in a similar way. Can't we just have one way to instrument the code so that I'm subscribing to one API in my multiple languages and then, well, run from there? And the answer is yes, but it's threefold or multifold. So one effort that Ben Seigelman signed off on initially was open tracing. And open tracing just tries to standardize the API. That's what they started off with. So that you have a standard API and that you can have multiple people implementing the backend of that particular API. So you instrument your code, then you get from somebody else an instrumented set of libraries so that you can go and spit that data out. They're also trying to eventually get to harmonize what's going out from an export format perspective. But the format is really the tracing piece, the tracing API piece. Multiple people have started to implement that. I said, well, Ben Seigelman started this whole thing, so Lightstep is obviously one of them that supports the thing. But you have also open source frameworks. Like in CNCF, we have Jaeger as a tracing framework. Jaeger supports open tracing. And multiple others, like pick your choice. There is multiple of them. I'm listing a few. There is another group also in CNCF, same forum, different efforts, that tries to go one step further. Don't only do the API, but also build a tool chain along with the API so that I not only give you the API and then say, well, vendor A, vendor B, vendor C, please implement that in your particular ecosystem, but go and build me a tool chain where I have a library, an instrumental library that goes hand in hand with the API and an export infrastructure that can link to the various backend systems so that I can export to, say, well, Jaeger again, Prometheus, couple of open source environments, but also, well, more like proprietary environments. Well, and the guys that complement this, and there's a third group by Alois Reitbauer, I think that's the right name, that is driving of Dynatrace. I think he's the CTO of Dynatrace, driving the work of W3C, where they're trying to go and specify, well, how do you go and transport tracing information or trace data using, well, parts of the HTTP header. So it's another portion. How do you get that whole thing across the wire? So where do these different guys apply in our framework? So I try to go and depict that a little bit. So open tracing is really trying to go mostly focus on the API and how do you instrument your app. That comes with libraries, which is why they have a say there, but it's a vendor that implements that. Open Census really tries to go and do the overall developer ecosystem toolchain that they're trying to build. And yes, well, all of them want to have a say of what goes onto the wire eventually from a trace data standardization perspective. Are we there? By no means. So there's open tickets in open tracing, for instance, on how to represent the trace data, maybe with JSON on the wire. And then, well, you're going to go and spit that out into your tracing backend, and that needs to go and consume that and expose that to you. So all of them, despite them quote unquote not being necessarily completely on the same page, have the same tracing model. So you have a trace, and that is kind of here, we're just querying, well, we're trying to get data into a particular cache. So authenticating, we're issuing a cache get, then we have a trace, and that trace reaches out to a backend MySQL query that comes back. So you see that darker gray that goes off to a different box. And then we finally can go and update the cache. The individual steps are so-called spans. And you can have a hierarchy so that one trace has a child trace, or one trace has a parent trace, so that I can go and correlate these individual things later on from a tooling perspective into one big picture. That's awesome. And you have tools like Jaeger, again, a CNCF project, where you can go and look at these traces, and then you can drill down. So you can see exactly on a per request basis what happens at what layer, when do I submit a Redis request, a HTTP GET call. So I trace all the way down, even with kind of details on kind of how long the call took from when to when, so I get really detailed information on how that thing progressed. So that's all cool. Now, if I said earlier on, maybe the HTTP GET request took us 652 milliseconds. Where did I spend the time? Who do I blame? Network, TCP stack, if the network, which network element, where did the delay queue up, what can be done and be attributed to the network and how? So could we marry that? And that's a discussion that the open tracing people and the open census people are really interested in having. But the question is, how do you go and get the trace ID that you have at the application layer down into the network layer and vice versa, and make the two speak a similar language so that you're able to correlate what happens on one layer to the other layer. So it would be really shit cool if you issue that TCP or that RPC request and you have another trace segment, a child trace, that tells you, yeah, you went into the TCP stack, then you went across router 1, 2, 3, you got the query on the router side responded to, and then you went via router 4, and then you went back. So you would have ultimate visibility into how these individual steps would work out. The problem is, well, I have my trace ID in the HTTP request eventually. How do I see that at the network layer? There might be multiple HTTPs going over the same TCP connection, so I can't really do a one-to-one mapping so that I say, well, I pass that on as an option if I open the socket. So something needs to happen there, right? So we have to go and answer that question eventually if we want to go and provide for that level of visibility that everybody would appreciate, the developer, but as well as the operator. The other question that we have to answer is, can we get to a format where the backend system can ingest and digest that data in a relatively correlated and uniform way? So if we're exporting trace information from IOEM, NetFlow information, and, well, these tracing information, and these guys are just about to embark to standardize that whole thing. Well, wouldn't it be nice if we would be able to go and correlate all that and have a full view? I believe so. So how do we correlate these metrics to the backend format? There is an open discussion. It's still an open issue from an open tracing perspective. It's open for 2 years now. And, well, what I missed out on this discussion is what happens at the transport layer. There was a really nice talk from Robin Marks on what happens with Quick. So layer 4, IOM gives you visibility up to layer 3. These guys look down to layer 5. Well, there's transport in between. So if you enlarge the picture, then you put the network into this whole trace data thing. So we have trace data from the application side, from these agents, but we also have network trace data that would all be going back into the backend system so that we can go and all correlate. That vision is there. Everybody could say, well, we can export into Kafka and correlate the various topics, but yeah, we need to go and get that done. If you look at that scorecard that we had earlier on, and well, I don't know whether you want to go to ask me again, but I have one.
Do you have a scorecard?
I have one. So the observation is, and I think that's very much driven from an app development perspective, as a developer today, I have to choose my framework. And that means everything is driven by the tool chain. Open Census, Open Tracing, W3C, all these guys just came across because we have this landscape of stovepipes that we want to go and, well, basically tear down. If somebody says Open Tracing, they don't necessarily say Open Tracing. They just like say, give me an Open Tracing system where I'm not kind of hooked up into one or the other silo forever. So the observation is really that the how drives the what. And, well, again, I think we've done network, we've done application. There is one layer that, well, we may not talk about that much, but if Benoit talks to his SVP, that's the only thing he cares about.
Thanks, Frank. So, okay, we've seen the network, right? The network we love, right? Great. We've seen active probing. We've seen the application. But the point is that, as Frank mentioned, we're missing the business view. Why do we do all this, right? Because there is a business intent at the end. And we need to correlate information that Frank mentioned. So basically, the config information that might give us the service information, along with the operational information, and along with the business view, right? And that might be coming from multiple sources: the application, active probing, passive monitoring, the operational information, etc. Those have to work together for what a business intends. That's why I believe that we have to add the service KPI, the context information, to the telemetry, so that whenever we get it from wherever, whatever way, right? And please let's not discuss protobuf versus JSON, right? I really don't care. But I need to get the context information, because if I'm in my big data lake and I've got so much data, the information, the data kills the data, right? I've been there with NetFlow, right, years ago, where we've got so many flows, it started to be difficult. And we're going to face the same thing. Take the 250,000 counters, time instances in a router, in a time series, and make sense out of it. So what we have to do is that we have to look at the service assurance parts, right? We need to tag in telemetry the context information directly, so that whenever we export it, we know what to look at for a specific service. And we've got the tree information of all services. And we've got the link with the application information, right? And we've got the full decomposition on where the problem is. This is tying telemetry for intent, right? Starting with service assurance, right? Yes, the dream and the vision is to do the closed loop automation. We want to go there. Maybe we want to we want to walk before we run and get all the building blocks there. Now, something we said we're not going to spend time on, this is the telemetry definition, because I like the simple one we had at the beginning, a collection process of useful operational data. Now, when I speak to some executives as VP, they don't care about my little time series of a counter, right? They want to say, what is the business impact with your, which business impact can you have by sending telemetry, right? Which useful information will you give me for my business? That's why we made up that new keyword, which is not there, business telemetry, just to say, if you speak to an SVP, this is what he wants to hear. And things such as, okay, in networks, what type of devices have operators, right? Is there dependencies? Can I do combined sales? What about licensing? Is the licensing fine? Can I sell some more licensing? Can I enforce it? What about the feature usage? Can I finally remove the 625 feature? Right? What are the customers using? This is the type of things that they mean by telemetry there, right? This is report the value, and that's something that we keep forgetting, right? Writing a small spec in the IETF is great, but if we don't see the big value, it won't work. The good news is that whenever they speak to me about their business telemetry, and they call that telemetry, by the way, right? While we call it operational telemetry, whatever. The good news is that we speak about the same information. We just need to package it in a different way, a kind of translation for a business view, right? I might need the interface counters, like the usage, and I might need the license and the feature and the inventory and all this. So it's the same information, just mapped differently. Now,
Benoit, are we ready for that broader agenda?
let's
Can we
cover
put all of these things together?
Let's do this together. So the conclusion now, for 3 slides. You know, we've been discussing multiple aspects, like at the network layer, at the application layer, at the business layer, right? And telemetry, for me, is a collection of many things. So cover that one, please. I'll cover the next one.
Yeah, so I think we need to figure out the what. And I think we spend a fair amount of time on the what. And the what is described by a model. Our favorite, whatever, Yang, whatever. If you want to go and express it somewhere else, it wouldn't matter that much. I think we need to really focus on the how, because the how is, from a developer perspective, how I consume things. If I want to go and consume the what, the how needs to be figured out. And those 2 things go hand in hand. If you sell me on the how, not on the what. If I can't consume it, no matter how well you describe it, I'm not going to go and consume it. And we got to go and figure out who for, right? I think that's the 3 questions. Who do we need to go and talk to? Who do we need to go and convince? Who do we need to liaise with as an IETF in order to go and get these things, this equation kind of summed up so that I have something that I can go and deploy? Because the solution requires all of the 3. Otherwise, I think it's of a single silo, we might not succeed. I think that's at least for the telemetry business, that's what we're seeing.
And I would say that, you know, we need like what? Specification. And we're pretty good at writing RFCs here, right? Check, we could do that. We're slow, but we're good. As Frank mentioned, we want to have the tooling at the same time. And the code, because otherwise we're going to fall into what has been happening, that there is code and tools, but not for the IETF specs. And guess what? In this world of automation open source, people will go and try things. And if it works, well, that works. And if you say, I've got the perfect specification 2 years after, well, that's too late. And the thing that we're missing sometimes is that we as a group, we need to reach out to the industry. And just thinking that, okay, we've got our spec, it's good enough. No, we need to go to all different SDOs and to the consortia and etc. And unless we've got those 4 different conditions, I don't think that we're going to be relevant. Or actually, depending if your glasses are full or empty, right? But I believe this is what we have to do as an IETF organization to get our solution adopted. Any final remark, Frank?
So how do you want to go and do that? So I think if I understand this, this means specification is good, but you really want to go and have a closer interlock again with running code, right? So that we go back a little bit into time where we had more running code and going that hand in hand with the documentation, so that you have a bar where you say, well, if you have running code and a spec, it might get more airtime. It's more relevant to maybe discussions that we're having here. That needs to be balanced, right? So in certain cases, open source got it wrong, and we're stuck with the wrong framework because, well, it's the only guy in town. So there is not, that is not an either or, that is not a discussion that, well, do this or do that. But I think we have to go more carefully consider how we bring these three things together, how we more frequently and better liaise also with other quote-unquote standard bodies that might not be called an SDO. CNCF does these things. They're not an SDO, but people care about it.
Okay, thank you. Excellent presentation. Couple of points that probably it was missing. Frank, you mentioned that CNCF, of course, you mentioned open sensors and open tracing and more. All the backend processing, stack driver, Prometheus and more. But what was missing in the bigger picture is if you plug in all these tools into a bigger architecture, we know as a service mesh, like SDU as an example. So for application layer networking, that framework is already established, and CNCF is rallying behind that increasingly to have their tools graduate from that machinery, like Kubernetes and SDU and more. So that is in the bigger vertical stack. We need to correlate or create a link between layer 7 application infrastructure or networking and layer 2 and 3 that Frank and Benoit you mentioned. There is a disconnect there, absolutely, that was a great point. And then how to linkage these two. Of course, your colleague Ed is trying to create something called network service mesh. And then where that IETF can come in and perhaps take some set of requirements from the SDU and network service mesh and all other components that you mentioned, create a list of those core requirements and identify the gap, and based on the set of requirements, develop probably some new API protocols or protocol extensions.
Thank you, Paris. It's there. The problem is there, and it surfaces very much, as you say, in network service mesh, where we are bringing together, well, the service mesh aspect, which is an application layer concept, basically, from Kubernetes, and the network world. And the guys in network service mesh would love to have something like open sensors or open tracing integrated, so that you have visibility across the board, all layers. The problem that we have there is in the first bullet. How do you go and correlate? What do you use as a correlation ID? Because your trace segment ID is something that only lives up to layer 5. We have something else at the network layer, but we have no way today to unlink that, and that's an ongoing discussion. So thanks for the question. It's there. People care about it. We don't have a solution.
Max Pala, Cable Labs. Very good presentation. I really like it. Our members, they operate large networks, and something like this, I think, is interesting. I don't have visibility on how they manage internally their own network, so I'm spitballing here, but that could be an industry that you might have open ears. They listen to what you're proposing, and the advantage there is that we have our networks tend to be a little more controlled. We manage our networks and basically the devices that access our networks. So that might be something that very valuable in our industry. And you were talking about more industry connections. I'll be happy to help you with that and to reach out to the right people.
Thank you.
Dan Bogdanovic. So you had there one in your table where you were having multiple layers. It was what and how, and you said that the IETF has the what sort of like checked, but how was open. It was the last slide in the first part of the Benoit's presentation. Yes, well, okay.
Go on.
Yes.
We're getting there.
Okay, yeah. So what I did this one, and I want to measure the network. And these days you showed up there are many different ways of measuring the network, and you can try it, but it's really not. There is not a unified way. The OEM people are trying to do that and provide us some of those tools. But you said there is what, but there is not how. I know that what is, I want to measure the network. What exactly I want to measure will depend on a case-by-case basis. Give me a common interface for the network measurement, and then not the vendors, although the vendors can also measure the network for their own performance, for their own performance reasons, to be able to improve the operations of the equipment, but also the operator will be able to say, I'm measuring this, and how I'm using those measurements for my own business application is something that I will do. We have many young device models in the IETF, but we have very few service models because we don't have the right participation. So when we are doing about the IETF specification, we have to be careful which part we are working on and not trying to go into the area where we don't have the expertise. So if we will try to do some specifications, let's provide a common interface how to do the measurement and not to say what to measure.
I would agree with that. Now, the point I was making about the feedback loop, the closed loop, this is binding the service KPI to your configuration and to your telemetry. This is the way to do it. What you're also asking is like the measurement, let's say at the IP layer, like the active probing that Frank mentioned. And Frank mentioned, like, yes, we should have the same interfaces, like, an all IP SLA or OWASP or T1 or In-situ-AM. Yes, I also want to get those APIs, because if I'm able to map my service up to my specific device paths, I want to be able to test this actively and passively. So we're in violent agreement.
Clarification on the service. The notion of service is overloaded in industry, Benoit. Services at the top layer, you can probably address that through your intent via the information models. But Yang is a primary data model, which is for resources.
Diane is going to answer that, and we spoke about it a few times, so his answer will be valid.
Routing is a service, and is being consumed by the high-level services. So when you talk about the services, anything that goes among multiple devices. There are some services that can be specific for a single device, but anything that you're running between multiple devices, you want to measure how that service is running across that, being it like a routing or something other than like an L2 and L3 VPN, which is using the routing in order to deliver that service. So there are different qualifications of its services, and it's not overloaded. You can be very specific when you're saying routing or a service or a VPN as a service or some others. You just have to qualify it right.
So what Diane means is service Yang models. Now I want to extend this definition, because a service in this full picture could also be an application that Frank is mentioning.
All right. Thank you so much.
Thank you.